Good morning, everybody. It's time to talk science again. Welcome to our format, Let's Talk Science. Again, we have a very interesting topic from the Institute of Production Management Technology and Machine Tools of Technical University Darmstadt. Please welcome Professor Matthias Weigold, who is going to educate us how we can move from here towards a climate neutral production. And for myself, I can say it's a very important topic, because we see more and more that we have issues from the administration, from politics, but also business to business to deal with reporting the energy efficiency of our production to improve things. And how you can do this, you can learn from Professor Weigold. The floor is yours. Please educate us on how to get moving towards climate neutral production. And to the audience, if you have questions, you should see a questions panel in your controls panel. So type away your questions and we will answer them in the end. Professor Weigold, please.
Yes, thank you, Mr. Voss, for the kind introduction and the invitation to the Let's Talk Science. Ladies and gentlemen, thanks for joining today's speech. Skipping your lunchtime, or maybe beside lunchtime, listen to this talk of today, which is about the climate neutral production. And I would assume that you are mostly from production environment. So I will also like to explain in the first part a little bit on the major terms when we talk about climate neutral production, and some words to motivate. And in the second half of today's talk, I want specifically give some examples and innovative approaches how we get to a climate neutral production. Okay, let's start with a graph, and this graph is showing the CO2 concentration in our atmosphere over several millenniums. And no matter which graph you are looking at, we always see cycles in CO2 concentration over 100,000 of years. But one thing that's for sure, we see a tremendous peak in the last years. And with this increase of the CO2 concentration in our atmosphere, and there is a one-on-one link to the rising temperatures that we also see, and where all of you are really concerned, I guess, when we hear the news of the last days in terms of wood fires and water temperatures and so on and so on. So the IPC, the Intergovernmental Panel on Climate Change, they came up with some scenarios. So this scenario, the scenario 1, would mean that we limit our global warming to the 1.5 Celsius, which is our aim. Others are towards constantly warming up, and so our main goal in all the activities should be to stay towards our goal, that at the end of this century we can limit and reach the goal of 1.5 Celsius maximum. Before showing more figures, I want to differentiate between three terms that often get a little bit confusing. The first term is a CO2 neutrality, the greenhouse gas neutrality is the other, and last but not least, the climate neutrality. So what's the difference? And the CO2 neutrality, I would start with that one, is when all CO2 sources and sinks are balanced. The disadvantage in that case is that when we get these balanced, the global warming still will continue. The greenhouse gas neutrality means, beside the CO2 emissions, all other impacts on the global warming refer to the Kyoto Protocol, such as methane and others, which we shortly formulate as the CO2 equivalence, which we get back to this topic later on. And finally, climate neutrality is our ultimate goal, and these terms describe a state in which the effects of the temperature influencing human activities and the neutral factors are balanced, and that the average global temperature remains unchanged. And this is our ultimate goal, and this is not only the effect of the greenhouse gas emission, it is also includes air populations or the changes in reflectivity, such called as albedo effect on the Earth's surface. So this is the ultimate goal. We, with our institute in Darmstadt, we are formulating the goal of getting to a climate neutrality, which in fact really we can, from production side, mostly influence the CO2 greenhouse gas neutralities as such, just for clarification. So when we look at our emissions in Germany in 2020, those are figures from the German Ministry of Economics and Climate Protection. We had an emission of more than 700 million tons of CO2 equivalents 3 years ago, and the direct emissions from industry are 8%. When we split the direct energy emissions, we see that another 19%, which we call indirectly, are caused by industry. So overall, we can say that 27% of the overall CO2 emissions are caused by the industry. This means we are one of the major areas, and this is why we should all care about these topic, besides transportation and others. When we now look at strategies which we can set up, I tried to summarize an step-by-step approach which we commonly see in industry. This step-by-step approach starts at first every time with the topic of accounting. And then we get to the optimization topics like minimization, substitution, we get to the compensation, and last but not least, in the strategy papers, we see also communication issues. I want to highlight the 3 steps in middle of this strategic chain. which is minimization topics. First of all, there we have the option to look at energy efficiency, material efficiency as well. It is a topic on the circular economy, and last but not least, the reduction of our final demand. And today, in this half an hour talk, I want to focus a little bit on the energy efficiency topic. Why? Because the energy efficiency measures have a significant share in the overall emission reduction potential. And when we look at a study that was set up from Boston Consulting 2 years ago, the study says that the theoretical saving potential of energy efficiency measures in the industrial sector could be up to 37 million tons of CO2 equivalents by end of 2045. That means in industry currently we are polluting roughly 200 million tons of CO2 equivalents. So that means roughly 20% of today's pollution can be reduced by energy efficiency measures. Yeah? On the other hand, we have the substitution option, which get more and more relevant the more renewable energies we get in Germany and worldwide. The electrification topic, substitution of material, green hydrogen, biomass. So today I also want to pick the topic of what happens if the renewables are rising. Then we do need more flexibility in our industrial behavior. And last but not least, to conclude this chain, the compensation issues, the certificates which can be purchased, the carbon capture effects, the various BECCS standing for the bioenergy with carbon capture and storage, the direct air capture storage, the carbon capture and storage processes and utilization as well, and not the topic of today. So, ladies and gentlemen, accounting. Accounting, also some brief introduction, because I don't know if you're all familiar with the topic of CO2 accounting already. And then some those which get on our table in the last month of research. The carbon footprint is a measure of the total amount of carbon dioxide emission directly or indirectly caused by activities. In addition, other greenhouse gases we have been at this point, which we then are assuming as the so-called CO2 equivalents. And when I am asking to my students, please have a guess, what are the average emissions from us in Germany in the last years? I seldomly get an answer, a feeling of understanding how much CO2 equivalent emissions we are producing in Germany. And then I also asked them, let's guess how much emissions you are polluting when you are flying a round trip to Asia. So just for an example, also some figures. The annually emissions in Germany is roughly 12 tons of CO2 equivalents per capita. And when we are flying, we are assuming Thailand, could be also other nations in Asia. So one flight to Thailand, a round trip, is already 3 tons of CO2 equivalent. So to get a kind of feeling and understanding what's all about of this topic. So back to industry and the types of balances we are facing to. On one hand, we are facing to the accounting which is done on a company level, and therefore when I can do this later, the greenhouse gas protocol is the abbreviation for GHG. Compared to the greenhouse gas protocol, we mainly look then on the company level and scope 1 and 2 items. When we are heading more towards the product specific carbon footprint, then the so-called scope 3 items getting more and more relevant. And we see in between that from company level to an local accounting to accountings from production lines, even to the machine level, we see a lot of question arising there in the last 2 or 3 years, more and more. And in my opinion, when you are looking at this more granular level and specifically to the product carbon footprint, the temporal measurements are a must-have in my opinion. That is important to know in my opinion, and therefore it is always a question of do we have automation approaches there, and how much effort is needed to get to the really interesting information. And just looking at the machine tool, this is a representative machine tool from our institute and a vertical lathe. And there we have inputs and we have outputs, and usually it is quite simple to acquire data which are from the side of electricity. Sometimes also the compressed air is already a sensor based by its installation. Then we see others where we have quite more effort, which are in our terms more the manual acquisition parameters like lubricants, the tool itself, the raw material. Yes, we do see companies already having a good data and digital backbone, but most of the companies we see a huge manual acquisition effort. And we have a third bucket, which is an estimation based on documents, on rough records. Sometimes an estimation really is valid. And one thing's for sure, if we don't get to a more automized level of data acquisition, I think there's a real huge gap towards scalability into the broad industry. And this is, in my opinion, one task for academia as well as for industry to think about these, and where standards in communication, in information modeling like an UMATI OPC administration shell might help to gain this more automatically. Okay, looking at the time, we see a lot of standards, and that's a real problem because we do not have the one and only standard. When I am asked by industry which standards should I know when it comes to accounting, and the the topic we see the ISO 14067 and 68, which gets relevant. That one is expected to be available end of this year, beginning next year. We do see the PAS 2050 and 2060, which is especially relevant in United Kingdom, for instance, and other areas. And we see the greenhouse gas protocol. And in my opinion, you should definitely look at the greenhouse gas protocol, getting familiar with it. And I decided to include these slides because just recently I had a discussion with someone really deep into this topic, but still was a little bit unsure about the greenhouse gas protocol and the three so-called scope items. And in the greenhouse gas protocol, we see these three scope items. The scope 1 is the direct emission. So for instance, when you have an hardening process, you're burning natural gas, that would be a one-to-one direct emission. With all your machine tools, mostly electrified, we buy the electricity and the purchase electricity, for instance, would be a scope 2 item, and scope 3 item are various thousands of different items, is upstream, downstream processes in the value chain, and so on and so on. So this is where it gets more complex. One message I would bring in today's talk is you have to have a look at the greenhouse gas protocol, because most of the companies will apply to this standard, and you should also get in touch with scope 3 issues. Even it is a tremendous effort, you need to get in touch with the effects of scope 3. Why? There was also a nice practical guide from the Mechanical and Plant Engineering Association 3 years ago already, in October, the guide on climate neutral production. And in this guide and in other sources, you see in mechanical engineering the effects of scope 3. You can always say more than 60, even 80, up to 90% is caused by scope 3 emissions. Excuse me. And this is the reason why you need to get in touch with also these more complex and diverse emission topics. Okay. After we finished several projects with industry, I can summarize some topics which gaining headache through all these projects. The allocation of the resource consumption is the first one. The accounting of the value chain, I just talked about scope 3 topics, is causing tremendous effort, and the question always is, do you get the information from the steps upstream and downstream sides? And there I think the data ecosystems will help with use cases which are in Catena X, Manufacturing X, in other bigger initiatives, we will see that there will be help by standardization and automation. And the level of detail is always a question. Is it enough information from enterprise level? Do I get to think about gathering data? How important is the IoT environment for our balance sheet? That is a huge question. And the last slide, which I want to end the first part, is the following. We had a really deep study on uncertainty factors in the determination of a product-specific CO2 accounting. And we have made this based on a real part in industry. And you see the different areas where we have a lot of possibilities. For instance, which database to use, which data we use in future to account the electricity we are using. What is the allocation approach for the production when we get this? Is it more on the production itself? Is it across the complete unit or factory, and so on and so on? And not time to go a lot deeper in it, but one topic which we saw is the data source is an important topic, but we saw in our last study that the topic how to handle the data for the electricity which is used is a tremendous uncertainty factor, and that maybe for discussion later on, maybe your experience, your questions, highly welcome at the FAQ later on. Now in the second half of my speech, I want to go into the optimization topic, and picking one topic of minimization, one of substitution, and I want to explain this a little bit around our ETA factory at the TU Darmstadt. So first of all, our research, our knowledge transfer activities are based on this vision to support you on the way to the climate neutral production. We have some basic elements which are very relevant, and therefore we are concentrating. When we are on the level of accounting, we scope all three items, but when we are in the optimization, which we are talking immediately now in the next slides, we are focusing on scope 1 and 2 items which directly are adjustable and to be optimized within your production. That is important. The ETA factory, I'm pretty sure you have already heard from our approach of this so-called real demon-strator, comes along with a lot of innovations, not only in the machine itself, also in the surrounding area, also in the construction, so in the building. And the really specific topic and this innovative topic is this cross-linked energy system. So we have what is typical for production sites, 3 temperature levels at the factory: a cold water network, 12 to 20 degree, a hot water network up to 40 degrees, warm water network, excuse me, and the hot water network up to 85 degrees. And we are coupling these networks between different machine tools and equipments. We are coupling this with storage equipment, and so on and so on. So we have chillers inside this factory, heat generators, and storage system for hot and cold water system. So this animation of this ETA factory is showing you a little bit the principle. So we are running our machine tool. We are also running our oven. So we have this heat treatment, and the one really major topic in production is that the waste heat is generated everywhere in the machinery, in the supply system, and there are efficiency measures which we call direct measures. So we can correct the design, we can install insulations, and so on. And we have the so-called unavoidable waste heat, and then the integration topic. And with this unavoidable waste heat, this offers great potential for the reduction of the demand when you are coupling and interlinking this topic with direct integration into other processes, into the also when you leave the system boundary to transfer heat to third parties is also very popular thought in the last month. And we can also convert this waste heat in other forms, and this is where we talk about absorption chillers, or even other topics in production. So I think we have a huge lever how to handle waste heat, which will always exist in production. And the question which we are confronted a lot of time is the question of, is it only possible in greenfield environment, or is it also possible in brownfield environment? The answer is yes. Greenfield environment is much more easy to have a huge integrative approach, but you can also do a lot of things in a brownfield environment. Looking a little bit at our time schedule, some examples on machine tools, on parts cleaning machines, on the oven. So we have a lot of efficiency measures around the machines in the auxiliary units, especially to run a machine tool more efficient. I think those approaches are public. They are known. A lot of machine tool vendors are aware of this. When it gets to parts cleaning for machines, for instance, we can also think on recuperate energy and adapt our planning and control based on an energy flexible planning. I get to this just in a minute, and so on and so on. So a lot of topics are needed, and beside these approaches, which I call hardware-based approaches, you should be aware that our digital transformation is also a good basis for this efficiency and flexibility approach, because the transparency you get in this factory is quite necessary and important to look at. So I'm pretty sure that the development of a really complete vertical through the management layer to all the layers to the field layer, where we connect all this data, we can acquire our emissions and energy demands is really necessary. We can, with these digital approaches, we can really face several issues. We can do forecasting topics, load shifting as is one topic. We can flexibilize production planning. We can optimize the machine tool states and their energy consumption. There is really a bunch of approaches which are known not only in academia or already in industry, how you can face, when you have the digital backbone, energy efficiency and flexibility matters. And talking about flexibility, I want to highlight one huge project. The project en-ergy is led by the Fraunhofer IPA Stuttgart, and en-ergy, we just started phase 3, which goes more and more into implementation. So we think with a huge consortium of universities and industry on the technical development for flexibility measures, the automation itself and its implementation, and last but not least, it is really, really important to also think on the commercialization effect on the market side, because all the technical approaches will not fly without the market view. And one slide talking about the flexibility topics is, when we get more and more renewable, we have to flexibilize our ways we produce in future, and we can flexibilize by measures which are on the management level, the company management level, the production management level, and in shop floor. We can think of production sequences, capacity planning in a high level. We can also think of when to start the orders or postpone, to interrupt orders, to get this more flexibilized, because in the end it is not only ecological, it's also economical effect. And in the shop floor we have storage possibilities. We can adjust process parameters, and the more we are heading towards more renewables, the more relevant the flexibility issues gets, and especially also in terms of substituting some sources, it is getting more and more relevant. So, ladies and gentlemen, at the end of today's impulse, I want to state out an initiative from the WGP, the so-called efficiency initiative. The WGP in Germany, the German Academic Association of Production Technology, roughly speaking, more than 50 different institutes Germany-wide are bundling expertise in the field of energy transparency, efficiency of energy, as well as flexibility, material efficiency issues, and the circular economy aspect. So really broad field of expertise are within the Association of Production Technology. And we are looking at single processes itself, at the machine side, at overall production lines, and towards the complete production supply chain. This is where colleagues of mine were coming together to support you in industry with these different topics, and one really good opportunity to meet, to discuss, to get support is at the trade fair of in September in Hanover, the EMO trade fair, where we also participating on the booth of the association, the Machine Tool Association, which is called a Future Sustainability, and there myself and other colleagues are participating to get you more insights and details into this topic. That's it for today's impulse. I'm looking forward to get one or two or more questions from the audience. Hope it was some informative minutes over lunchtime, and thanks for joining.
Thank you, Professor Weigold, for this overview of what's going on and what needs to be considered and what can be done to turn our production more efficient, avoid waste, and in the end move towards climate neutral production, hopefully. To all the audience, please, if you have any questions, type them in the questions panel. Meanwhile, from my point of view, I mean, this is a topic we are also dealing here at the Machine Tool Builders Association. How do you see the awareness and the readiness of the companies you deal with when it comes to reporting of their respective footprints and optimization? What's your impression?
My impression is there is more and more interest. Especially since last year, when the electricity prices went up, we had a direct link into more awareness, and we see that bigger companies are starting to ask small medium companies to get their product specific carbon footprint, so they are asking themselves how to answer these questions, which are coming more from huge companies. So the awareness is there, the willingness to think of the steps are there. In my opinion, the big challenge is where to start. Which fruits to pick first to get an first step into this topic, but the awareness is there, definitely.
Also a good point, because where to start means usually if you start, it involves effort and cost. On the other hand, certainly the overall benefit is we need to do something about this planet we live on, which you showed in your introductory slides. But when it comes to, let's say, business, is always the question, is the effort worth the money? So what would you say if companies want to start today to reduce their footprint? What would be the first low-hanging fruits, as we call them, where to get started immediately at a very low effort?
Mm-hmm. Yeah, maybe the first answer to your question is it is always worth to think of the efficiency topic, because efficiency is one-to-one linked to economical issues. Yeah, and we do see that return on invest calculations are getting less since the last year. So we are talking a lot of times on an ROE of 2 or 3 years. So it is always worth to think on the efficiency topic. And in the end, I think, and that is the feedback I get from industry, that it will get to a differentiator of a worldwide challenge to see, okay, where we as a German industry in machine tools have our advantages compared to other nations. And I see that in the field of efficiency, in the field of CO2 reduced production, we are at the forefront, and we should use this momentum on our side in Germany, because there could be a huge export benefit.
Thank you also for pointing to the new opportunities that certainly will bring to us.
Yeah.
I don't see any more questions. So once again, thanks for your presentation. Thanks for sharing these insights with us. And you already had a perfect advertisement pitch towards EMO. Come and meet Professor Weigold, meet us all, meet the sector, meet the industry at EMO Hannover in September, and learn about all the efforts that are being undertaken to get a grip on climate efficient production. I'm sure there's going to be a lot to see, especially at that special exhibit you have been talking about. Also stay tuned in for more to come for the next rounds of the Let's Talk Science webcast. And if you're interested in the former editions, go to the EMO Hannover website. You'll find the link to all the podcasts we had over the last 1.5 years. So if you're interested, you find all the infos you could want to. Once again, thank you very much. Have a great afternoon. Enjoy lunch, and see you later at least at EMO. Bye-bye.
Bye.